For information theory and coding, there is a subject, signals and systems, which reveals the meanings and operations of memoryless and memory systems, which is used in information theory subject. So basically, signals are of many types described mathematically, and one of the examples will be a unit step signal. The characteristics of unit step signal is drawn on the graph, and what it does is mathematically its value is equal to 1 when the all the values of time are greater than equal to 0. So when time is greater than 0, here the value of this signal, which is dependent on time, is 1, and the value of this unit step signal, which is dependent on time, is 0 when value of time is less than 0. So this is the graph, this is the mathematical definition. One thing that you can do with this, that if you shift the time, this is called delay, a delay by 1 second. Suppose these numbers on time axis are in seconds. If you delay it by -1, or rather just not think about delay at present, don't think about graph, just update the definition of unit step function. So you will get the output will be 1. There is no time variable here, just the amplitude, and time variable here changes by -1. Since left hand side you did that, you treat the inequality, take -1 on the right hand side. So time, when it is greater than +1, the value becomes 1. And similarly, for when time is less than 0, time is updated as t-1, as done by tweaking the signals basic construct representation. So now treating this inequality, taking -1 on right hand side gives this. Then t is less than +1 indicates a value 0, t greater than +1 indicates a value 1, which is drawn here. So the signal seems to be delayed in time towards right. You can do many different operations. So these may be advanced in time. You can do time compression, time expansion, if I am right, because if you do it, you try on this gated, make it gated signal, and you will realize that which one is compression, which one is expansion. So you will realize by doing this. It's very easy, so I'm not showing, and it is not a very major part of this subject, information theory. It is treated in a totally different subject, which is signals and systems. That is an interdisciplinary subject. So continuing, we can do many other operations, and this is just one signal example. There are ramp signals, there are delta direct signals, and again I want to inform that a whole subject is dedicated to this study of signals and systems. But since in information theory we need this as a primer, this is a brief review of that part. Again, another topic, that is, suppose we have a battery voltage that depends on time. So time is the independent variable, it exists, and during some part of time, depending on the time when the battery exists, its voltage will be 9 volt. When it is used, some point after some point in time, its voltage will fall, its voltage will deplete, chemicals will burn out. So what I want to tell you here is dependent and independent variables exist. Now it is not necessary that time is always a independent variable. Let us take another case. Suppose you are in India, it is 6 a.m. today, and at the same time in England it will be in they will be 5.5 hours early in time. I mean early, they will be back in time. So there will be 12:30 a.m. and on the same date, and today on the same date they have just started the day. India has already done more time on today's date. So if you understand what I mean, that has been drawn on this graph. And here I want to emphasize that time is now depending on the distance where you are located. So the independent and dependent characteristics are not permanently attached to a variable. So signal is defined signal input signal is defined as a function of one or more variable. So this is one single input single output system. This is basic definition of a system. There is an input, there is an output, and the system behavior is there, that is defined as y is equal to xt coupled with some system behavior. So suppose there is this system static, which is also known as memoryless. The characteristics of such system is that the output at any time is a function of same time input, and dynamic is the output function of any time, either present, past, or future. Let us do some examples to see how that works for a system. So just draw a general system. You are given with a question that there is a system whose output is given like that. So output is, you just take the input and multiply it with a variable a. So let us test if it is a memoryless system or a memory system, static or dynamic. So if you put value of time 0, +1, -1, you will see that all the inputs that made this output are in the same time. That's why it is static. Take a contrast example. Here the output, what output does is that it takes an input, and that input is actually added to 3 times the time shifted input. So this is the output. When you give this input, the output will be calculated with this equation. Let us do one example of time value. Put it equal to 0, +1, -1. Just directly putting +1, you see that the input x -1 was involved in generating the output at +1. So this is past time input, and that is current time, say current time output. So if current output is depending on past present values, we have defined that that type of system is dynamic. This is how you test dynamic and static systems. There are another breed of systems which is time variant and time invariant. For a time variant system and invariant system, there is a simple test. You feed the signal, you delay the signal, and then put it into the system, get an output. And in the second case, you take the signal, put directly into the system, and the output is fed into a delay unit. If both the outputs are found same, then the system is time invariant. Otherwise it is time variant. Let us take an example. Suppose there is a behavior, there is a system defined by this behavior, that the output is calculated, the output is found by taking the input and multiplying it with this. So let us put it to test. Let's take the system, first put it in delay. So the input is put into a delay box, the delay will be produced, a delayed signal will be this, fed into the system behaves like this, it multiplies a 2 to this, there it is, and a t to this, t, there it is. This is the output. Now before delaying, straight away if you enter the signal input, it will give this output, which is the definition. Now delay this, then you will have this. Note that y1 is not equal to y2. That means it is time invariant. Sorry, time variant. It is varying in time. Okay. So you can do many other examples, and then you will find these are the questions that you may get in your exams. And if you test it like this, you will get the results. So I've just written the answers, and you can test it on your own. There are another class of systems categorized as linear and non-linear systems. Linear systems follow homogeneity and superposition. And let us take an example to show you how it is checked if a system, given system, is linear or non-linear. Here there is a system defined like this. This is an example. Let us test if this kind of system will be linear or non-linear. If you put x1 in this system, you will get tx1t as an output, which is the definition. Another input, if you take x2t, you will get an output like this. And then if you sum both up, you get this. Now hold on to this as equation 1. Now let us put this input as a summed up input. So let us sum this up and put it as a single input. Let us call it x3. that will get you this. And when you re input the x3 value, you will get this. Now this is equal to this, equation 2 is equal to equation 1, then the system is treated as linear. Take another example. So let us take an example of non-linear system. Suppose we have a definition like this: output is squaring the input. So let us first go for the input x1 giving this, x2 giving this will give you, the sum of these will give you this. Now you feed the input as a sum called x3. It is squared. Squaring this will actually give you something else, which is a square plus b square plus 2ab, whereas the sum of this will be x squared 1t plus x squared 2t, and 2x1 x2t, which you would get here, is not there. So equation 1 is not equal to equation 2. Okay, so that's why it is non-linear system. It's just a brief overview. You can do many different examples, you can get many different questions, but since information theory does not treat this very well, since other theory is included in the main body of the subject, so I'm just giving a hint that such things exist in other domain, another course, so which is used here as a primer. Causal and non-causal systems, the output, or causal is cause, some cause should produce the output. If there is no cause, then the output should not exist. So future value should not be participant of creating a current output. So definition is causal output depends on present past input values but not on the future. So there is because of that it happened, because of this it happened, but because of future it cannot happen. That is not a cause, that is presumption. So that kind of system will be non-causal system. Again, you'll get some examples and you will work out and you will find out that the output is dependent on present and past times only, not on the future times. There is one more example here and you can test if it is causal or non-causal. So that is a brief review. Next we will go dive into information theory again, the main part.